Adafruit. We bring do-it-yourself electronics to life here in our New York City factory. On our YouTube channel, you'll discover hundreds of unique open source projects that you can make at home. Explore the A to Z's of electronics with AdaBot and friends in Circuit Playground. Learn to build internet-connected projects with hardware like the Raspberry Pi. Become acquainted with a variety of technologies and the forces that make them work.
Hello.
Tune in every week for Ask an Engineer with LADYADA, the engineer. Meet makers and their inspiring projects from around the world. Show off your own creation in our on-air weekly hangout, the Electronics Show and Tell. Get inspired on 3D Thursday, where we'll share a new project you can build. Join LADYADA streaming live engineering, sharing maker business secrets, and real-time surprises from the desk of LADYADA. We've got something for everyone, so subscribe to Adafruit on YouTube and explore our video library. Welcome to the world of Adafruit.
Live from New York, it's Ask an Engineer.
Hey everybody, we can't stop, we won't stop. We're always here broadcasting every Wednesday at 8 p.m. It's me, LADYADA, the engineer. With me is Mr. LADYADA, who is an unstoppable force, and I'm the immovable object. And we're here at the Adafruit factory here in downtown Manhattan, where we do all the design, manufacturing, testing, shipping, all the electronic goodies that you love. They're made right here in this factory. We're here on the factory floor, and we're going to broadcast to you.
No matter what.
No matter
Half the internet's down right now, but that's okay. We've figured out some workarounds. Okay, so want to do the show?
Yes, of course.
Okay, on tonight's show, the code is Minerva, and this is a special code, 15% off.
What?
Yeah, we're bringing back the 15% code just for tonight only, and I really, really mean it.
This is your last chance.
Yeah, and
the most you're going to get.
We'll be introducing Minerva the Owl. Show and Tell, we rebroadcasted it from a pure.in. With people who like video technology. Mailbag, packet will stop by, read your letters to us. Time travel, a look back in the world of makers, hackers, artists, and engineers. Some made in New York factory footage. Nimbus, the friendly cloud entity, is going to stop by. 3D printing, new products, answer your questions. We have a top secret, trivia question, all that and more on Ask an Engineer.
That's right.
Yeah.
Let's do this thing. Let's do this thing so I can go home and play Final Fantasy 15.
All right.
Sorry, what?
Code's Minerva, 15% off all the way up to 11:59 p.m. tonight. We have some free deals and more going on. Pins got back in today. We have feathers at $150, pins when you purchase, and we also have free UPS ground. Go to adafruit.com/free. The free pin is at $99 or more, feather 32.4 at $150, and UPS ground at $200. And of course, if you want to see the pins and learn about the free deals, here's a quick video. Okay, so that's our pin promotion right now. This is Ask an Engineer every Wednesday at 8 p.m. Show and Tell every Wednesday 7:30. We have our same-day shipping. If you're in Manhattan, check out before 11 a.m. Look at the Adafruit holiday shipping guidelines. They will save your holiday.
Yes, and we purposefully make the holiday shipping deadlines really conservative. We want to make sure that even if there's a snowstorm, who would believe it in winter, a snowstorm, or ice storms or an airport gets shut down, you'll have an extra day or two.
Yeah.
So please, please, please don't wait till the last minute. Get your orders in by that deadline, and it'll give you a little bit of a cushion. Make sure that you get your holiday gifts on time. We want to make sure that you have a great holiday.
And here are some cookies. Yum. Okay.
Yum. I'm
So
hungry.
So we did our show and tell. As the internet and the tweets saw, Hangouts was down, so we used this new service, appear.in, and then we did a screen capture via Wirecast, and then broadcasted it into YouTube Live,
Will
which
anything
was
stop
working.
you?
No.
Nothing will stop you.
And what I'm going to do is I'm going to have a backup plan to have that in place each week, and it actually turned out pretty good.
Yeah.
And people were able to stop
We
by.
actually had people come by because they saw the URL.
Yeah, they're
and
like, okay,
let's
I'll go show up my project. So, LADYADA, what was on
Okay,
the show and tell this
we
week?
had a short but a very effective show and tell. We had Now and Pedro, who showed off this week's 3D Hangouts project. We'll be talking about that later. It's the Commodore PET Mini with a really adorable little Charlieplex LED display. So check that out. It is gorgeous. It's just, it has served no purpose other than to entertain and make you love it. So if you're a Commodore PET fan, you should absolutely check that out. Tony D is doing video guides and tutorials on making holiday lights using MicroPython. So Tony D has done a lot of projects with MicroPython, tutorials on like individual sensors and displays and OLEDs. And now we're pushing forward and not just doing library guides, but also project guides. So how can you actually use MicroPython in real life? And so what I like is Tony's actually getting all the experience that beginners are going to have. Doing these very common beginner projects is a great way to test out the MicroPython build we have. It's still for developers only.
Yeah.
So people who want to play around with it, you can. It's up on GitHub if you'd like, but
You can play along.
You can play along, and we're kind of trying to
Real-time
figure out,
development.
yeah, we're trying to figure out like how do people think that how do we envision people use MicroPython? How can we make sure that people have a good experience? Is there anything we're missing? So as we're doing these guides, we're like, oh, you know, this was a hang up, or this crashed. You know, we're finding all of these bugs. So we're doing our own beta testing before we release into the wild. So check that out, and we'll have some cool hardware with MicroPython in the next couple months. And then we had visitors. We had Kirby, who's been working on a Pi Zero library project for us, and also made a Hot Wheels speed trap using two sensors that can detect when the big brake beam sensors can detect when something passes over them. So they detect how fast the Hot Wheel is going by measuring how long it took between each pass. There's two gates. So it plugs into a standard Hot Wheels track. One Bitsy, can't remember the fellow's name. He makes really, really gorgeous boards. He has a Kickstarter for his OpenOCD list debugger. Check that out. I would love it because I would love to not use OpenOCD if I could avoid it. But it also is an OpenOCD adapter, it sounds like. I mean, you can use it with GDB, but maybe you can use it with OpenOCD as well to program your boards. Also some really cute Cortex boards that he's making. Check those out. They're Adafruit black, so maybe we'll carry them. And then Chalky did a Maker Charades. He tried out the tutorial that I wrote over the weekend on using a Feather ESP with Alexa, and also added the Wi-Fi manager support. So you don't even have to program in the Wi-Fi SSID and password. You can actually, it creates its own access point, you connect to it, and then you can select the Wi-Fi and it stores it.
We have an Echo demo that we're going to show tonight.
Okay, great.
Yeah.
Yeah.
You spoke to a little tube computer and you asked it to turn on NeoPixels and it did it. And then it added itself to our shopping list.
Yeah.
And then we
Yeah, it
bought
did.
another one. So I have another one coming.
That was funny. It's
Yeah.
like you say echo, echo. It's like, okay, add an echo. No, don't add it.
I've added an echo. It's shipping. No returns.
But it's a really easy, fun tutorial. We'll talk about that later. But I've seen like 2 or 3 people now try out that guide, and it's pretty easy to do, and it's so far the easiest way I've seen to create Internet of Things devices that can work with your setup, because like each system is so unique and different that if you have an Echo, this just works directly with the Echo. You don't have to worry about like joining a Zigbee network or like.
It's like the easiest IoT.
It was the easiest.
It's harder to set up some of the things that we have in our apartment because you have to have a bridge, you have to authorize devices, you have to find them, you have to name them, you have to put them in a group. This
is really easy.
It just worked.
It just worked.
Yeah.
Okay. So that was what's show and tell.
All right. All participants on the show and tell get an As Seen on the Show and Tell sticker. We do it every week, 7:30 p.m. Eastern Time. Just look for it anywhere now.
And thanks for being cool, everybody. We'll keep broadcasting, but you gotta be cool. Be cool.
Yeah. We'll keep doing this. Part of the Adafruit Live series.
Yep.
We've been broadcasting up a storm. We did, I think, 3 or 4 Deaths of LADYADAs. In fact, the ones that we did this week, we did Saturday Night Hacking, and then Sunday Night Hacking, and then the world premiere of the Circuit Playground CMD.
I think the Saturday and Sunday night. Sunday night was.
Sunday was Echo Night with the Huzzah.
Echo. The Saturday night, I think, was. I was working on the Trinket M0 and the Gemma M0. So if people want to see what is coming down the pipe, check out these streams, because you can see me working on next gen hardware.
Whatever we're working on that's going to be out in the store, it's kind of like a half an hour if it's not out yet. But you can ask.
And you can ask.
Yeah.
I answer questions. People ask questions. So we made a crystalless bootloader for the SAMD, and then we made a Trinket and an M0, a Trinket and a Gemma that uses the SAMD M0.
Yeah.
So I'm kind of excited for that, because I really want to upgrade the Trinket.
The other cool thing is there's lots of people in the maker community that stop by. So Caleb Kraft from Make stopped by. And I said, hey, we should do this Open Cyber Monday. I'll talk about that in a bit. But we teamed up. It was part of it. It was neat. Some folks from Hackaday. Micah stopped by. Like, there's lots of people in the maker world who do projects.
Is it the coolest place to hang out?
If you do electronics on a Saturday night.
It's cool. Who doesn't? Well, a lot of people don't. But we do.
Yeah. Everybody I know does. That's Tony D. More MicroPython. And you can catch Tony's video that he showed off the project on the show and tell. This one is the holiday lights with MicroPython. So it's part 1. He's going to continue to do more of these, but this is a really good one to get started with MicroPython and make a festive project.
It's great because it uses MicroPython, uses LEDs, start on a feather, and then maybe expand to something else. So yeah. I'm excited, and we're going to start seeing people making their own MicroPython projects too. So this is one of the things that we invest in. So a lot of people say, like, why should I buy from Adafruit? I mean, like, hopefully nobody viewing this is watching, because you're watching, so you know that we do
I ask all the time.
You ask all the time, why do you buy from Adafruit? Well, we actually spend so much time and energy and money investing into new platforms, development, tutorials.
Yeah, we like breaking all the stuff so you don't have to.
Yeah, we like getting MicroPython. This has been like a 6-month project that we're going to be doing. And we're serious about it. We're going to put a lot of effort into it, and we don't ask that you back a Kickstarter. All we ask is that when we're done, if you like the hardware we design, support us that way, because we love to do this stuff and we want to keep doing it. But to do these bigger projects, we have to invest a lot more time and money.
Yeah, it's a good deal.
But we still give it away for free to the community.
Speaking of good deals, 15% off. Code's Minerva. This little owl is going to delight you. Oh, this thing this owl does.
Oh, wow, in space.
Space owl.
Space owl.
Anyways, that's what the 15% code's all about. Okay, mailbag. Packet mailbag stops by every week. Hello. We read this in our all-company weekly meeting called State of the Fruit, but we also read these to you. This one's from Rick. Simply to throw a praise at you, not that it matters to you, but I do a lot of internet traveling and buying. I bought my first products from you just last week. I'm very impressed with your presence on the internet, the clarity of your product descriptions, and your general approach to business. I'm an old school guy who spent his career in all sorts of software and control systems, from the early days with machine languages to PLCs and ladder logic. Now I am going to teach myself C. Kudos to you guys. Keep up the good work and be proud of what you've accomplished. Rick. Thanks, Rick. Next up, time travel. Look back in the world of makers, hackers, artists, and engineers. Happy birthday, Pong.
Yes. Beep, 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 beep.
Atari announces to release a Pong, the first commercially successful video game. Pong is one of the earliest arcade games and the first sports arcade video game. Its table tennis sports game features simple two-dimensional graphics, while other arcade video games such as Computer Space, that was the one?
Computer Space.
Computer Space came before. Pong was one of the first video games to reach mainstream popularity. A bunch of lawsuits and more. All things good start from carnage and people being angry with each other.
There's only like 64 pixels here, but people like
yeah. So read the history.
killed each other over it.
Yeah.
64 pixels.
Yep. Okay. Some
Okay.
open source hardware news. This is what I was talking about before. So we want to do something for Cyber Monday besides just, hey, buy stuff. Every year we have CyberCat, and CyberCat tries to do good in the world. Watch out, Kana.
I don't know if this is the good reprogrammed CyberCat or is this
Yeah.
the original
Well.
bad T1000 cat?
Anyways, what we did is, in addition to saying, hey, there's like cool things that you could probably buy, we teamed up with Hackaday, Maker.io, and DigiKey, and we started Open Cyber Monday. And Open Cyber Monday was tweeting and posting and sharing cool organizations like the FF, WordPress, Wikipedia, Creative Commons, Open Source Hardware Association. If they
Archive.org.
Archive.org.
I donated to them.
Yeah, if they do something with open source, Python Foundation. So it was just hundreds of people tweeting and retweeting and saying these are the things that are important to me that I use on a daily basis. So that was kind of neat.
Yeah, we give away a lot, and we don't take donations. Instead, we just sell hardware, so you get a donation and you get a free gift, basically.
Yeah.
But a lot of organizations, they're not hardware based; they're software based. They perform services that you use on a day-to-day basis, and it's easy to take them for granted. So
Yeah, every time there's a giant security issue, they're like, oh, that one guy who maintains SSL was like sick and he couldn't pay his medical bill or something like that.
yeah, there's so much of the internet and hardware and software that is, based on open source software, which is awesome. I mean, we can do so much because of this huge underpinning, but these people need support. So this holiday, we gave a bunch to nonprofits, both software and hardware and related and not. And this is a really good year to donate to groups because
I figured if you had the credit card out for Cyber Monday, you may as well toss $10 to the FF or what. There's organizations that
even $5, $10, even every little bit really helps.
Okay.
And the FF is one of the cool organizations. If you donate to them, they certainly will not sell your name out.
Yeah.
They will never send you a letter.
They will give you stickers.
They'll give you stickers.
The other thing is we started doing stuff on Snapchat. So you'll see.
You get these glasses.
Yeah, I got the spectacles. So you'll see this video on AdaBot. That's our account. So add us, and we're doing some discounty stuff and weird things. But
if you want super behind the scenes, we'll be in bed reading data sheets.
Yeah. So
Exciting.
I thought I would just show these on the overhead. There's a teardown, and I linked to them and everything. But there's a little camera, and when you press the button, it lights up, and we'll have the camera looking at the camera. So
this is the light.
It's doing 10 seconds of recording right now, and it stores it, and it has this app,
Nice
Snapchat app,
fading.
and it it's like a nice data slush that next time you open up your phone, it's most likely there. And these are LADYADAs. I steal them from her, and we got pictures of cats and stuff like that, but. It's pretty neat, and it's one of the first wearables. I have a post on the Adafruit blog, and you can see 12 years of Phil putting cameras on his head.
Dude, we have
some
done
of
so
yours.
much cameras on our head. I like these because they do one thing, and they do it
pretty well.
And I think that's key. Having done my time at the wearables group at the Media Lab for a couple years, and working with the people there, some of whom ended up working on Google Glass. I think that Google Glass was a little bit too much. It was too ahead of its time. And what I think about spectacles is interesting is there's only one button, only one function. You can't reprogram it. You can't load apps onto it. It's very bare bones, but it does pretty much what everybody wants, which is okay, I want to record video and audio. That's all it does.
I rarely disagree with you, but I'm going to disagree with you about saying that Google Glass was ahead of its time. It was the wrong launch. it was the technology and the hardware is fine, but the way it was presented.
I didn't say how far along. Could be like 25 years from now.
It was clearly made for.
It was made for Android developers.
For like Android developers, where Spectacles, it's just made to hit a button and everyone knows what's happening, and the technology.
Like Fitbits, right?
Yeah,
like
the technology is not in the center.
Look, your phone can do activity tracking, but it's like too complicated. People really like the clip it on, it does one thing, all it does is track your motion or whatever. And I think that especially since this is what most people wanted from glasses-based wearables, right? It was that and the memory glasses demo where it would remind you stuff. But it would be very easy to update this to have a little OLED, behind it that would flash in the corner of your eye. Like you could always update this version to add a little display later if you want, but having it do just this is quite nice. Okay.
Anyway, so you'll see that this footage that I had just at ADABot on Snapchat. And we started this ADABot Snapchat account 4 years ago. And, ADABot is on there as well. So that's a photo from...
That's the old pick and place.
Old Adafruit from 3 years ago.
That's real old.
So, like I said before, the code's Minerva. And why is the code Minerva? Well, this is one of the new additions to Circuit Playground. Minnie stopped by. She is one of the few people in the world that makes puppets, and she is the one who's taken our two-dimensional drawings and she's turned them into puppets. This is some of the making of.
Oh, cool.
And I wanted to show Minerva, so I'm going to get Minerva right now.
Okay, later.
Yeah.
Grab the puppet.
And this is Minerva, and we'll have some videos that explain a little bit about Minerva and more, but this is just, I only have one of the wings with the
I'll do the wing if
rods.
you do the mouth.
Yeah, and Minerva is just one of the many characters that'll help young people learn gears, and when Minerva talks, you'll hear the gears turning and things like that. But we wanted to have another character. ADABot is kind of the young person that's exploring the world, very new, and where Minerva has a lot of information to dispense. So, yeah.
I'm not a good puppeteer. I'm going to stick to the hardware.
And we're working on...
You're good at puppeteering.
Beep, beep, beep. We're working on K is for Kit, so that'll be finished soon. We just filmed it 2 weekends ago. Mm-hmm. So that's in our series. LADYADA is for Electronics, Circuit Playground, which is also the name of our hardware. So, right, that's Minerva. And that's why the code is Minerva tonight. Okay, next up, some scenes from around Adafruit. It's from Black Friday. We were just moving around a bunch of parts. We make all this stuff here. We have a very gratifying slow motion from
this is cleaning
the selective solder machine.
Oh, man. That's gratifying. That's some dross. Get that dross out. Ugh.
And we got this. And next up, the Adafruit Learning System. We have how many tutorials, LADYADA? 1,120.
Thanks.
What were some of the tutorials this week?
Okay, so we had, let me see. Last week we definitely had the Adafruit VL 53 locks time of flight micro LiDAR. So I think this week was the top 4 tutorials. So we had we have the Easy Alexa or Echo control of your ESP8266 SL. That's the tutorial I did on Sunday. Check that out. It's really easy and fun. If you have an ESP8266 Feather and you have a Feather wing, you could basically plug it on top. And I basically got a relay clicking on and off. I said like, Alexa, relay on, Alexa, relay off, and it would just do it. Hopefully you guys don't have an Alexa, or you would just...
Or relays.
Or relays. NeoPixels on, NeoPixels off. So you can basically just tell it to control your ESP Huzzah board. So that's really neat. We have a micro tutorial on the time-lapse spy camera. Some people who bought the spy camera were like, hey, I want to turn this into a time-lapse, like you say, and I don't know the code or how to write code. So we just wrote a teeny amount of trinket code just to toggle the pin for you and show you how to do it and how to wire it up. And you can use the battery to control both the trinket and the spy camera. We had the 3D Hangouts project for this week from Noah and Pedro, the mini Commodore PET with Charlie Plexed LED matrix. It's a 3D printed Commodore PET. I mean, it's adorable. And then we put, instead of going with the TFT, we decided, let's go with a Charlie Plexed LED matrix. So it's got like cool designs, and it kind of looks like it's writing code. It's got a little matrix animation, and Philby wrote some great animations for it. So really took advantage of the fact that it's got multiple. You can have 8-bit PWM per pixel, so it's not just LEDs on and off. You actually get like gradient effects, so some really cool gradient effects. And then the new product tutorial, the Adafruit VL6180X time of flight micro LiDAR distance sensor, which we will talk about in the new product section. So there's a tutorial on how to use that.
Okay. We're releasing more learning guides every week.
Every week.
We try to combine some of the show segments. So this is Nimbus, the friendly cloud entity. I'm just going to play this 20-second video. This is you talking to the Echo and things happening.
Okay, so now I'm connected, so I can say, Echo, turn pixels on.
Okay.
Oh my God, that's so bright.
That's cool.
So you can see it's pixelating.
Yeah. So it's from LADYADA, where we explore all these ideas, and we use a lot of the newest stuff to make sure it works with DIY electronics, because while an Echo is closed source and you really don't know what's going on, you can have it work with electronics that you do know what's going on.
I like it because the thing is, okay, so I like the Philips Hue bulbs that we have, but they're kind of expensive. And you got that LED strip, but like, I was always like, well, why don't I just make this myself? And now we could make an LED strip that just like has warm white LEDs, and it will light up and turn off, and it's going to be a lot less expensive.
A lot easier to use too. And
a lot easier to use than the Philips. You don't have to do like some weird Philips thing. You just say, you use your Alexa or Echo. And a lot of people are getting these helpers. And I like that Amazon made it easy to integrate it. It fakes being a Wemo.
Yeah.
So it doesn't work with the Belkin Wemo app, but it doesn't, the Alexa doesn't do authentication because they don't care. They're like, I don't care if it's a real or fake Wemo. So it does it that way.
As long as you bought it from Amazon.
As long as you bought something from Amazon, it's happy.
And then Todd's working on this cool Bluefruit wireless Unts, and I'm just going to play that. Okay, and a reminder, we have Adafruit IO. It's our free Internet of Things service for makers. We're probably going to start charging for it soon, so you should probably start using it if you want to tinker. We'll have a free tier and account no matter what. That's IO. And we also have our Internet Things Bill of Rights. We put it up on GitHub, and we're working with the EFF and others. So when you use services from us, or hopefully others, you'll know who owns your data, what happens with the feeds, and you have a certain expectation about how things happen. So we think that's a good idea. Mm-hmm. Yeah. And also how to maybe secure these devices so they don't turn into botnets. 3D printing, we moved 3D Hangouts to Wednesdays. So that is a programming note, but we also have the video this week of the cutest little Commodore.
It's so cute.
In this project, we'll show you how you can build a mini replica of an iconic computer from the 1970s. This project uses an Adafruit Feather M0 and LED matrix to make a retro-inspired computer that resembles the Commodore PET. It's a neat little DIY project that's fun to build and makes a really cool gift. You can use the Adafruit GFX library to easily display text and even draw shapes to make custom graphics. Download and modify the Arduino sketch. You can find the link in the description of this video. To build the enclosure, you can 3D print the files yourself or have a service like 3dhubs.com print them for you. We 3D printed the parts on a Sigma 3D printer from BCN 3D. There's a total of 10 parts and it only costs less than $1 in material to 3D print. You can get the full list of parts in the tutorial for this project linked below. We'll start by installing 2 headers into the pins on the LED matrix, then install the LED driver on top. We'll need to solder the headers to make a solid connection. Once we finish this side, we'll flip it over and solder the header pins to the LED driver. And now we have our little LED matrix package. Here's a pro tip: place the tip of your finger over the excess pins while clipping them short to avoid projectiles. Next, we'll need 2 pieces of wire to connect the slide switch so we can power the circuit on and off. We'll only need 2 leads from the slide switch. Then we'll tin the leads and connect the 2 wires. Now we can solder the 2 wires from the slide switch to the enable and ground pins on the Adafruit Feather. We can plug in a battery to test out the slide switch. When the enabled pin is tied to ground, the circuit will power off. Next, we'll need 4 pieces of wire to connect the LED matrix and driver to the Adafruit Feather. Strip and tin the tips of each wire and solder them to the 4 pins on the side of the LED driver. And with the wire soldered to the driver, we can then connect the LED matrix to the Adafruit Feather. The 4 connections will go to serial data, serial clock, voltage, and ground. Now we can do a final test of the circuit. Be sure to check out the full tutorial for this project to get the circuit diagram and step-by-step instructions. Onto the assembly, we can start by installing the faceplate into the display frame. A dab of superglue can permanently bond the keypad to the keyboard cover. Then attach the keyboard cover to the frame of the enclosure. We'll do the same for the base of the display. Tap the 2 mounting holes on the Adafruit Feather and mount the PCB to the 2 standoffs on the bottom of the enclosure cover. We'll need to insert the LED matrix and slide switch through the bottom of the frame. Now we can place the battery into the enclosure and fit the wire through the arc. Lay the bottom cover over the enclosure frame and secure them together using machine screws. The LED matrix mounts to the display cover by press fitting them together. Then we can install the cover to the frame of the display. Insert the slide switch into the holder of the enclosure back cover. The display frame has 2 keys that fit into the slots of the display frame. The back cover with the slide switch can then fit into the back of the enclosure. Lastly, we can print the label on sticker paper and crop it out. This is totally optional, but it really adds those final details to the project. And there you have it, a retro-inspired mini Commodore PET. Thanks so much for watching. Be sure to thumb up this video if you like this project, and don't forget to subscribe for even more projects from Adafruit.
Nice touch with the little subscribe on there. And then we have a time lapse. like an Alexa storage holder. You could put an Alexa inside there. So again, just a reminder, we moved 3D Hangouts to Wednesday. So Wednesday is Action Chapter's 3D Hangouts, Show and Tell, Ask an Engineer, and then we've been doing almost a LADYADA every night, and then we have Desta Tony D, then we've got videos from John Park. We got lots of stuff going on. Oh, you know, the video I didn't grab this week was from Erin. I'll grab it. I'll grab that next week, yeah.
Oh, that's right. That was true. I forgot. She did it. Oh, man, I feel bad. Because like this weekend was so long, I forgot that was a new tutorial this week.
Yeah.
Okay, next week we're going to do it double up.
All right. It's new product time, LADYADA.
New.
Yeah, all right.
New. We don't have that many news, so I have to make it very exciting.
No, it's fine. We're doing good on time. So this week, what do you got?
Okay, so start off, we have a new sensor. This is the VL6180X, sometimes referred to as the VL6180. The official name has an X on it, but whatever. It is like the sensor from last week, a time of flight distance sensor. This one is a little bit different. It has a range of about 0 to 200 millimeters instead of 50 to 1.2 meters. So it's got a very small range in comparison to the other one. But it does have a built-in lux sensor, and the code is a lot simpler and a lot easier to use. It doesn't have a full, like, complicated API. It's actually pretty simple to use. You just tell it start a measurement, and then you read the measurement back in millimeters. So I've got this demo here. You want to go to the overhead?
Yeah.
I can basically do the exact same thing, but live.
Yeah, we also have a new overhead. This one is it's a 4K overhead from Elmo that just came out. And if you're into desktop cameras for doing electronics, I don't know.
So it tops out at about like 170, 180 millimeters. Officially, it's like, up to 100 millimeters. We can do about 200 millimeters. Yeah. And I have a delay. It's actually much more responsive than this. And what's really nice is it's detecting the thing. It's very, it has a very precise measurement element here. So if
and you can see the laser flash.
Yeah, the little laser flash.
Yeah.
So what's nice is that it's not like the IR sensors that have like a huge cone of light or sonars. It's a very precise point of light that gets emitted, and then it measures the time of flight back. So this is kind of good for smaller, closer distance measurements, but we carry both because I think people want both. This one's a little bit less expensive too, but check them out. I think if you're using something, if you don't need the distance, this will do just fine, and it's a lot faster, and the code's a lot smaller. So that's the new VL6180 distance sensor.
Yeah. I gotta say, this is a really good overhead. I believe I'm a connoisseur of overheads.
This is a great overhead.
Yeah.
And what's nice is that there's a light, but it's not too bright.
Well, I didn't even turn it on. That's from another light. Is
that a reflection?
Yeah.
Okay.
So this is the additional light. So we're gonna try this with your microscope stuff too. But look how.
That is very nice.
Yeah, and I'm not even as. Let's get in.
You want to zoom in?
I think I can get about this close before it starts not working out. Turn off the light.
Yeah. Wow.
Yeah. This is beautiful.
What's nice is the OLED looks so crisp. It's like fake.
Yeah.
So it looks like it's drawn on.
Yeah. Okay. Well.
But yeah.
We found overhead. This is the Elmo 4K high definition.
Yeah.
Elmo. All right.
This is really nice because I can now do projects with like I used to have to like wire up a full demo every time, and I'm going to be able to do more interactive demos because I'll just use now I can just use a feather with an OLED feather wing. So whatever we're displaying, I'll try to have a demo that goes with each one.
Yeah.
Yeah.
Okay.
All right, so that's the new product there.
Yeah.
And then
this week, the star of the show besides you is the map of learning. Let's travel on the Adafruit Learning Map. We'll go to Blinky LED Boulevard. We'll go to Switch and Button Street. Analog Input Alley, stay away from that. Capacitor Concourse. Piezo Buzzer Parkway. Function Fast Lane. This is all part of Metro. And these are all the different banners and more that we made. All aboard Learn Train. Learn. And
So we had a Metro Monday.
We have a Metro Monday, and we launched our pack, but I just wanted to show some of the videos that you'll see on the site and more with Metro. And what's cool about the Metro and all the things that we put together is, we're in New York, so we use the subway all the time, and it's very, New York-like, and we've had all sorts of spinny videos and stuff like that. And these are the sounds from the Spring Street station. It's not too far from here. Some close-ups of the board. And, we kind of want to look crazy in New York. Great job.
It's fun 'cause it's like a little gritty.
It's like the hacker arduino. So, the Metro goes on the rides.
That's a good one.
So Metro going to move stuff. And so that all leads up to the new product of the week, which we're very proud of, is the Metro Starter Pack.
Yep. We wanted to offer people a starter kit that uses the Metro. It's our popular Arduino starter kit, but now in Metroified. All of our example code still works with it. It's completely compatible. But some people like having the LEDs on the edge, and it comes with an on-off switch and has a micro USB, not a DC. Micro USB, not a printer B type connector for USB, and it's flat on the bottom. So we're going to be also doing some more stuff with Metro, so tune in. The family will grow, much like the Feather family has grown.
Yep. And with that, LADYADA, with new products. New. Okay. Code's Minerva. Remember that cute owl that was here?
Hey.
15% off in the Adafruit store all the way up to 11:59 p.m. This might be the only 15% off sale, so you should do it. And because everybody's been so good, it's not out yet. Don't ask time.
High def.
Get out of the vault and get into the light.
All right, let's try this out. Okay, wow, this is a good. Yeah, so turn on the light.
I'm gonna turn on the light. I'm just gonna hit focus. I don't think you should turn on the light.
Okay, hold on. Well, I'm gonna straighten this up. So
Yeah,
this
you tell me when it's where you want.
No, that's great.
Yeah. Okay.
Yeah. So this is a new feather that K-Town and I are working on. This is Vision G, I think. We're doing a lot of work, but it's worth it. It's the NRF52 feather. So it's going to have CP20104 as a USB serial converter, has an SWD connector. We're not sure if it's going to come with this as soldered on because it is a little bulky, but it allows you to use a J-Link to do debugging on it. And you'll be able to program it over USB. It comes with a battery charger and all that good stuff, reset button. And all the GPIOs are brought out and have the feather compatible. It'll be feather compatible, so we'll make sure that it works with all of our feather wings. So the NRF52 is kind of nice because there's an Arduino core for it. There's a lot of real-time operating systems that are being ported to it. It's a good upgrade from the NRF51, which we love so much, but was a little challenging to develop for, especially at the lower end, the 16 kilobyte RAM end. Anyway, so it's coming out sometime, but not yet, so don't ask.
Back in the vault.
Back in the vault.
This is like a Disney vault, but different.
What?
All right, everyone. So we're going to do questions, post them up in the chat.
Yeah, questions time.
Yep. All right. So can't answer the things about the...
Don't ask.
Yeah.
It's not out.
But we're in Facebook tonight because Twitch is down. So put your questions in the What's the difference between the Uno and the Metro?
The Uno and the Metro use the same chip. The differences are the Metro, we put all the LEDs on the edge so you can see it even if you have a shield on top.
Edge.
You can switch the Metro to be 3-volt logic, which is handy sometimes if you're, for more advanced users, you need to interface with 3-volt devices. You can just cut a trace and solder a pad to turn into 3 volts. And it has an on-off switch. So that's like the main reasons. Other than that, it's pin compatible, function compatible. It uses a different USB to serial converter chip. The one that we're using, we get good pricing on, and so we were able to lower the price of the Metro compared to the Uno, so it's less expensive. So that might be handy also for some people.
Okay, is the TV Begon coming back in stock? Yep.
Yep.
Greetings, LADYADA. I'm looking for a Class D amp. I see that auto switches, speakers, and headphones when available.
What you'd have to do is get a headphone jack that has the switch built in. There's ones that have like a little switch that's built in, and so when that's plugged in, it connects the shutdown pin on the Class D amplifier, and it shuts down the amplifier. That's how you would do it.
Okay.
But you have to find that headphone type that has a switch built in.
Is an NFC feather possible?
It wouldn't be possible to have it all on the feather. We would probably have an external attached antenna. So we're thinking of maybe doing something like that.
Okay. Is there a place on the learning system that compares Arduino, Raspberry Pi, Metro, Feather, Wing, etc.? I'm new to all this, and so I don't know where to start. Sort of. We go by projects mostly. So I would say look at the project you want to do, and that will help you. Like the Raspberry Pi is very powerful, but not always portable, for instance.
Yeah.
Where Feather is very portable, not necessarily as powerful as a Linux computer.
Yeah, we do talk about it on the individual product pages, like why you want to pick it, but usually you go with the project you want to do, something similar, and then see what they used. And if it's like small, you want a Feather. If it needs a lot of power, you'd use a Raspberry Pi.
Okay. Is there a battery charging hat for the Pi Zero?
No, not that I know of.
Okay. Let's see. What kind of internet-connected projects would it... oh, gosh, they're coming in. What kind of internet-connected projects would make sense to use the Wicked Feather for instead of the ESP8266?
Projects where you need TLS, a lot of security. You can do bidirectional authentication with the Wicked module, which you can't do on the ESP8266. Nobody has added that support yet.
Yeah.
It also has a lot more GPIO and capabilities. It has like a DAC, and it has so many pins and a lot of analog pins, so it has a lot more functionality. So if you're like, oh, I'm running out of pins, that's when the Wicked would be.
Want to do any commerce, like?
Yeah, like Amazon AWS, if you want to use their AWS IoT platform, only the Wicked Feather right now works with it.
LED question part 1. I'd like to set up some individual color LEDs for a costume. I want the LEDs to be controlled by various button switches located in different positions. Different positions on the costume. When the color turns on, I want the other colors to turn off automatically. How can this be done with simple wires? Switches, resistors, and more.
We have toggle switches that are single pole double throw, which means that when you connect it one way, it connects 2 pins, and when you connect it the other way, it connects the other 2 pins. So you'd have one LED connected on one side and the other LED connected on the other side, and then when you switch between the two, it'll switch. You'll be able to turn one or the other. It'll go between the two, and that's how you would. You just wire the LEDs that you want on one side, and then the other side, and then you just switch between them, and then connect the middle pin to power, and that'll just automatically switch them. That's the easiest way to do it.
Going back to a previous question, someone asked, is there a comparison of the boards? Sort of. Make has a board guide, but they didn't include a lot of the popular boards that people use. So it's incomplete, but it is a guide.
Yeah.
So just got it. They don't have everything that a lot of folks use. But I think they updated on the online site. The print version, I think, is already a little hard to keep relevant because there's a lot of boards come out. Let's see. I just started with the pick, and I'm having a hard time learning how to take and use input. I'm pretty experienced with Arduino. So do you know this pick chip?
Yeah, you're going to have to look at their example code. I mean, I haven't written any PIC code in a really long time. The PIC 12F, geez, that's kind of an older chip, I think, right? I mean, 12F maybe? I don't know. Maybe it's, because I used the 16F84. That was the last PIC chip I used. But yeah, it's going to be a little different. You have to be more specific about like setting pin directions, and you're going to have to find the example code that they use and then try to reuse that as much as possible.
Okay. Want to provide GPS tracking and logging. What's the best Raspberry Pi Zero Ultimate GPS, Breakout, or GPS hat? Adafruit Ultimate GPS Featherwing with Adafruit Ultimate GPS Logger Shield.
I would use the Feather.
I'd use the Feather.
Because it's portable,
Yeah.
right? It's going to be lower power.
Yeah.
So I'd use the GPS Featherwing with one of our Ada Logger feathers.
I think the Pi is a bit of an overkill for that.
It's a little overkill. It's going to be tougher.
Okay.
We have an example code for the GPS Featherwing for logging, I think.
Adafruit Jobs
Shield.
Board. It'll be coming back soon. We're working on another version. I'm trying to make a speedometer for high-speed RC cars. Is there a specific type of inductive sensor I should use?
No, I don't know what you would use. I mean, it's actually the one thing I'm not very good at is like robotics speed sensing. I know a lot of people use optical encoders because, you just have a wheel and then you can just measure the ticks on the optical encoder. But I don't know.
Okay. Do you have any of those switches you mentioned for input, one output, I guess for the costume?
I have single pull, double throw, and and I have ones that have 2 switches in them. If you look in Adafruit under toggle switch and just see which one.
Okay.
It's kind of tough for me to understand what you want. You can post in the forums if you have like a diagram, that would really help, and then we could figure out. Because it's hard to understand if you draw, like, I want this here and this there.
I want this to do that.
And then you're like, what's the black box that does this? It might be just an Arduino or something. Would take the button switch and then do all the things. It's an easy Arduino project.
Yep. Any large e-ink hats in the project pipeline? Well, there's the crowd supply one that Jarek is working on, and he's.
It's not a hat though.
It's not a hat, but I think if this works out, that would be one of the things.
Yeah, the papyrus hats are cool. Right now we only carry the small one. Maybe we'll carry the larger one if people like it a lot.
What's your take on using a read-only file system for preserving SD cards on a Raspberry Pi? Is it worth the trouble?
You can do it, but I'm not so sure that that's exactly what. I mean, you have to write something at some point, right?
Okay.
So,
Does the Metro or can the Metro use the Arduino IDE?
yes.
Okay. When using TFT displays on Pis that plug into the GPIO header, what's the best way to add other devices?
All of our Pi TFTs break out the GPIOs, so you can just connect a cable or whatever to the GPIOs that they're either broken out on top or in the bottom through another header, and then you can just connect to another device.
Okay. Can you turn piezo sensors into contact closure switches somehow?
They're not contact closure switches. They can only sense vibration. Contact closure, you want like a reed switch or something.
Okay. Is the new laser sensor sensitive to daylight?
I think it probably is affected by daylight, but I don't think it's like strongly affected. Like I don't think it's like, oh, it doesn't work at all in daylight
Okay.
because it uses an IR laser.
How does one find a makerspace? Well, you could go to adafruit.com/hackerspaces, and those are the ones that stock Adafruit products. We treat them like resellers. And then you can, I think, go to like hackerspaces.org, and then I think on the Make site, there's maker spaces that participate in the maker education stuff.
Yeah.
I'd say Google for that one. Let's see. Do you allow MOSFET on table counters? No, we chase them off. We say no cat.
No cat.
And then I'm a high school student working on a Raspberry Pi 3 base eye tracker to detect a distracted driver. What programming language do you recommend for using image processing?
We did the
Simple
space traffic.
CV?
OpenCV.
OpenCV?
Yeah, we had a project on Learn. It's for the older Pi, but it's probably adaptable for face tracking. So check that out, whatever that was. I think it's OpenCV. There's examples for doing eye whites. I mean, it only works if they're not wearing sunglasses,
Okay.
of course, but then you can use that to detect maybe their eye motion.
Follow up. Oh, this is a good idea. You can find makerspaces through meetup.com. Yeah,
Okay.
that's right. What are you looking for the next processor after the SAMD M0?
I want a SAMD M0 with like twice the flash and twice the RAM.
Okay, well, at Mel Microchip, watch the show.
But that said, the next feather,
Call us.
the next feather will be there's going to be an NR52, which you saw, and then the ESP32, which I've done some videos on trying to finish that up, but I'm waiting for the ESP IDF to get released to 1.0 because I want to fully test it before fabricating a whole bunch.
Okay, and those are the questions tonight.
Okay.
Woo! Wow. Okay, it's trivia question time. Giving something away.
Yeah.
Give it away, give it away, give it away now.
We're going to give away the VL6180 sensor.
Okay.
Yeah, that sensor. It's a nice sensor.
Yeah?
Yeah.
All right, what are the rules?
Rules are if you've won something before, you can't win again. Only one winner per my lifetime. If you have won before, please sit on your hands or go make a sandwich or eat some leftovers or do something other than telling people the answer because we want everyone to have a fair chance
Yeah.
of winning.
Okay. Are you ready?
Yes. So type in the chat the answer to Phil's question, which is coming up right now.
In 1877, Thomas Edison demonstrated the following for the first time.
What?
What was
Thomas
it?
Edison.
Thomas Edison
What did
demonstrated
he demo?
what for the first time?
What year?
1877. If you go to the latest time travel post, you'd probably see it. "42" is usually an answer, but nope.
Yeah.
Let's see.
And there's no Twitch chat.
Not tonight.
No Twitch chat. So if you're on Twitch, get off
Amelia
Twitch.
Earhart, Jordy LaForge, all good guesses. Oh, guess who got it? Mike
Charmander.
Charmander, Phonograph, congratulations. You got it. Email support@adafruit.com. You won. Email support@adafruit.com and tell them that you got
3316.
PID 3316. Phonograph is correct.
Okay.
Edison demoed Larry King on radio. Yeah, that's funny. He's still alive. All right. So that's the show tonight.
Okay. Let's go home.
Epic show.
And I'm going to work on some hardware.
Yeah, we're going to work on
I got to
hardware.
work on that SAMD circuit playground.
Yep. All right. Well, thank you, everyone. Don't forget the code is Minerva. 15% off, which is unusually
Unusual. And
large.
it's not going to happen again for the rest
Support
of the year.
owls. That's what this code's for. And thank you, everyone. Everyone from Adafruit thanks you. This is just one of our latest company photos. Thank you, thank you, thank you, thank you, thank you. Thank you all the folks who help us remotely, help us here every day. And thank you for supporting an open source software and hardware company like Adafruit with your purchases.
We do this thing because we're doing this thing.
Yeah. And here's a picture of a cat. And here is your moment of Zener.
Doom.
A little Circuit Playground video I'm going to play too. Bye-bye.